I'm going to quickly review answers and just some quick notes on these problems for your review for your test on Friday. We're going to solve this system. I'm going to use substitution. I'm going to take what y is equal to and substitute it in place of y in your second equation. So I get 3x minus the group 3x minus 1 equal 9. So that's 3x minus 3x plus 1 equal 9. 3x minus 3x is 0, so I just get 1 equal 9, which is false, so there is no solution. Number 7, tickets to games of a local basketball team cost $12 for students and $16 for adults. For one game, $3,700 were collected and 250 tickets were sold. How many of each kind of ticket were sold? Write and solve a system of equations. So I'm going to start with saying that we're going to let A equal the number of adult tickets and let S equal the number of student tickets. So we have these totals. We have the total that there were 250 tickets sold. So I could say A plus S equal 250. We also have an amount of money. $3,700 was collected. And we know that it cost 16 for adults and it cost 12 for students. So we've set up a system. So now we've written it, we're ready to solve. We want to know the number of each type of ticket. So it doesn't matter whether we're going to solve for A or S first. I'm going to solve for S. So I'm going to multiply this top equation by negative 16 to get rid of the A. So I'm going to get negative 16A minus 16S equal negative 4,000. Keep the bottom equation the same. And we're going to add these two equations together. And we get negative 4S equal negative 300. Divide both sides by negative 4 to get S is equal to a positive 75, which means there were 75 student tickets sold. Now I've got to figure out how many adult tickets were sold. So I'm going to take this easy little equation, A, the number of adult tickets, plus S, 75, equal 250. That was just that top simple equation. And when I subtract 75 from both sides to get A by itself, we get that A is 175. So to answer the problem, there were 175 adult and 75 student tickets sold. Number 12, solve the system algebraically. I'm going to use elimination. And the reason I really like this method here is I have opposite coefficients already. So when I add these two equations together, these y terms will cancel. They add up to 0, giving me 3x equal 12. And I can quickly find that x is 4. Now I want to go back and get y. So I'm going to take either equation. I think I'm going to take the second one and say x plus 3y equals 7, where x is 4 plus 3y equals 7. So I get that 3y is equal to 3. Divide both sides by 3, and y is 1. And I like to write my ordered pair for x and y. So I have 4, 1, and I'm finished with the problem. Number 13, solve the system. I want to be very careful about something here. I have my x term, then my y term equal 8. But on the second equation, it's the y term, then the x term equal 2.5. So I'm going to rewrite these. We have 4x minus 4y equal 8. And my other equation, I'm going to write my x term, 4x plus y equal 2.5. So now my x terms are lined up, so are my y terms, so are the equal signs, so are the constants. And we have the same x terms, so I could just simply multiply that bottom equation by a negative 1 to get 4x minus 4y equal 8. And then the bottom equation is negative 4x minus y equal negative 2.5. And I could add these two equations together. The x terms eliminate, and I get negative 5y equal 5.5. And then divide both sides by negative 5 to get that y is equal to negative 1.1. So we found y. Now to get x, I'm going to take either of my original two equations. I think I'm going to take my second one and say, okay, y plus 4x equal 2.5, where y is negative 1.1. And then I'm just going to solve this for x. I'm going to add 1.1 to both sides to get 4x equal 3.6. Divide both sides by 4, and x is 0.9. So I get the ordered pair 0.9, negative 1.1. I'm finished here. EE.8, number 3, which ordered pair is the solution of the system of linear equations? Well, they cross right here at negative 4, negative 2, answer choice A. Number 4, for which of the following systems of equations is the ordered pair negative 8, 4 a solution? So this is x and y, and we just want to know if it's true for both. So for the first one, for problem A, we have 3 times negative 8 plus 4 times 4, and we're going to see, is that equal to 8? Well, we get negative 24 plus 16 is negative 8 equal 8. That's false. So since the first equation is false, then we know that they can't both be true, so that's not correct. The next one, we have negative 2 times negative 8 plus minus 3 times 4 equal 4. We want to know if that's true. Well, we get 16 minus 12, which is 4, so 4 does equal 4. So that one was true. Checking the next equation, we have 7 times negative 8 plus 4 times 4. We want to know, is that equal to negative 40? Well, that's negative 56 plus 16 is negative 40, which does equal to negative 40. So that one is true, because both equations are true. For our next one, we have negative 5 times negative 8 plus 2 times 4 equal 32. And we get 40 plus 8 is 48 equal 32. Well, that's false, so that one doesn't work. The next problem, negative 3 times negative 8 plus 5 times 4 equal 44. Well, we get 24 plus 20 is 44 equal 44, so that's true. And trying the next equation, 6 times negative 8 minus 5 times 4 equal negative 68. We want to see if that's true, so we get negative 48 minus 20 is negative 68. So, since the left and right side are equal, then choice D is true. For choice E, we get 3 times negative 8 plus 8 times 4. We want to know, is that equal to 56? Well, we get negative 24 plus 32, which comes out to 8, and that is not equal to 56, so that one is not true. Number 6 asks if the ordered pair negative 5, negative 4 is the solution. So here's our ordered pair where they cross. It's where x is negative 4, y is negative 5, so no. It swapped the x and y coordinates. Number 7, Matt concluded that this has no solution. Is he correct? No. These are not parallel. They will eventually cross. Number 4, looking at part D, how many solutions does this have? Well, I can look at it and I can see that this part is all the same. If the right side were the same, then this would be infinitely many, but it's not. So this is going to be no solution. And then looking at part E, I can see that the second equation is just the result of multiplying the top equation by 2. See, I get 6x plus 2y equal 26. So they're identical. So that means infinitely many solutions. And I'll zoom out and mark those on the screen here. No solution, and then infinitely many solutions. Number 4 on EE.8c, there are 25 coins inside a container. Some are nickels, the rest are quarters. The value of the coins is $4.05. Let N represent the number of nickels and Q the number of quarters. Which system represents the situation? Okay, so we know this much. We know that N are the nickels, Q are the quarters. So if I said N plus Q, I get the total number of coins, which is 25. I also know the total value of the coins is $4.05. And I can get the value of the coins by knowing the value of nickels and quarters. A nickel is 5 cents, or 0.05 N. And a quarter is 25 cents, or 0.25 Q. And so I've set up a system now, and it does match answer choice C. And that's all it asks you to do here. Number 10, Jesse owns a sporting goods store that sells skis and snowboards. The store earns a profit of $52 for each pair of skis sold and a profit of $64 for each snowboard sold. If Jesse's store sells a total of 83 pairs of skis and snowboards and earns a profit of $4,892 in November, how many pairs of skis and how many snowboards did the store sell that month? So we want to know the number of skis and the number of snowboards. So I'm going to call the skis X and I'm going to call the snowboards Y. And I know that there were a total of 83 pairs, so I can say, well, X plus Y is 83. I also know that it's a profit of $4,892, 52 for the skis, so 52X, and 64 for the snowboards, so add 64 times Y, and we get the profit, 4,892. So now I just want to solve this system for both X and Y, so it doesn't really matter what order we solve it in. I'm going to start by getting rid of X. So I'm going to multiply that top equation by negative 52, which the result is negative 52X minus 52Y equal negative 4,316. And then the second equation will stay the same. And we'll add the equations together to eliminate the x's and get 12y equal a positive 576. Divide both sides by 12 to get that y is 48. Now I need to get x. So I'm going to take that top equation, x plus y, which is 48, equal 83. Subtract 48 from both sides. And we get that x is 35. So to answer the question, x was the pairs of skis. So we can say 35 pairs of skis. And y was the number of snowboards, and 48 snowboards.